Welcome to the pre-calculus video for algebraic notation and rational exponents. In this particular video I'm going to be focusing on the rational exponents portion. So let's get started. Okay, before we roll into example 9, I just wanted to give a quick refresher that if you have the square root of a number, say like the square root of 5, that can be rewritten with rational exponents. It's 5 to the 1/2. And if you want to be more generic, if you have the nth root of some variable to the power of m, you could rewrite it such that the index, which is the number inside the radicand, is your denominator, and then the power is your numerator. So if I was taking the 7th root of 6 to the 3rd, I could write that as 6 to the 3/7. So that's going to be useful in the first example we're going to look at. The other useful thing that we need to recall is if I have a number raised to a power, we can, let's do this, a cubed squared. We can distribute that power in so that what we wind up getting is a to the 3 times 2, which is a to the 6th. So if you wanted to think about that, what we have is a to the 3rd times a to the 3rd. So that's a to the 3rd squared. And since there's 6 a's, we get that answer. Okay, let's take a look at, I think it's 9a. So the notes include some tips. I'm not going to go through them, but I encourage you to read them and use them as we work through these problems. Let's just get started on 9a. So, 9a. The first thing we should do is we should get rid of radicals. So in doing that, I can write this as 2ab cubed squared 5 times a to the 1/2 b to the 5/2. So doing that just took the square root out of this scenario, and that's usually a really good first step. The next thing we would like to do is try to distribute exponents in as needed. So 2 squared is 4, a squared is a squared, and b cubed squared is b to the 6th. So we had to distribute that 2 to all 3 terms. There's our first piece. The second piece we have nothing to distribute, so I'm going to leave it as is. And then we want to start combining like terms. So we have 4 times 5 is 20. Then we have a squared times a to the 1/2. And a squared times a to the 1/2 is the same as a to the 2 plus 1/2, which is a to the 4/2, 5/2. And then finally we have the b terms, and we have b to the 6th and b to the 5/2. So that would be b to the 6 plus 5/2, or b to the, let's see, 6, 12/2 plus 5/2 is 17/2. So there's our simplified form for part 9a. Alright, a tip for 9b that we'll get into. If you have a fraction and you've got some variable raised to a negative power, we'll just put this over 7, what we can do is get rid of the negative power by moving the term to the denominator. 7 stays on bottom, and we're left over with a 1 on top, because it's not written in here, but there is an implied 1 in the numerator. Or the reverse, if it's in the denominator, we could have like, we'll say 18 over b to the negative 5. We can move that piece to the numerator, And if we did that, the thing that's left over is the not written but implied 1 that exists out front. So that's going to be useful in solving 9b. Let's take a look at it. So the first thing I'm going to do is I'm going to get rid of the radical. So let's write this out. What we have is 2u to the 5th v to the negative 2 all raised to the 1/2. And that is over 3u to the negative 1 v to the 3rd all raised to the 1/2. So remember that 1/2 comes from the square root, and the denominator is the index of 2. From there, we can distribute our exponents in. So we want to do that wherever possible. So what we wind up having is 2u to the 5 times 1/2 is 5/2, and then v to the negative 2/2. If we distribute in the denominator, we're going to get 3 to the 1/2 u to the negative 1/2 and v to the 3/2. Remember, when we distribute a exponent, we multiply our exponents. So there's a implied 1 here. So 1 times 1/2 is 1/2. Negative 1 times 1/2 is negative 1/2. And 3 times 1/2 is 3/2. Moving forward, we can distribute the 5/2 in further, so that what we wind up getting is 2 to the 5/2, u to the 5/2. Then let's simplify this v, because the fraction can become v to the negative 1. In the denominator we have 3 to the 1/2, u to the negative 1/2, and v to the 3/2. Now we want to start combining like terms. I'm going to start with the v, because I think that's the easier one. We can take our v to the negative 1 and move it to the denominator. Similarly, our u to the 1/2 can move to the numerator. So what we have is 2 to the 5/2, and then in the numerator we have u to the 5/2 and u to the 1/2. In the denominator we've got 3 to the 1/2. And our v to the 3/2 is there, and then we've moved v to the 1 down. This allows us to combine our u's. So 5/2 plus 1/2 is 6/2, or 3. It allows us to combine our v's. 3/2 plus 1 is 5/2. And then our numbers don't simplify down too much, so I'm going to leave them as is right here. I think that this is, relatively close to simplified, though several people would argue we could simplify these numbers down a bit further. So let's try to do that. And this would require reintroducing the square root symbol. So what we really have is the square root of 2 to the 5th and the square root of 3 to the 1. And we could think of that as the square root of, what is 2 to the 5th? 2, 4, 8, 16, 32. So the square root of 32 thirds times u to the 3rd over v to the 5/2. So there's kind of a variety of ways you could lay this out. Depending on the instructions or the platform that you're using, it might tell you, we don't want any denominator variables. So in this case, we would have this is the answer. So that's another way. Any one of these three is, I think, an acceptable simplified form. I'm personally partial to this look or this look, but if I ever gave you a problem like this, I would be much more clear in how the end product should look. What's important here is that we are properly using the rules. So an exercise in simplifying using these exponent rules. All right, the next example, 9c, is very easy. So let's get to it. Whee! Okay, 16 to the 3/4 we know can be rewritten if we wanted to as a radical expression. So the denominator is the index and the numerator is the power. This might be a little difficult to solve in the head. What is 16 to the 3rd in the head? So another way we might write this actually is the 4th root of 16 all raised to the 3rd. And either one of these are acceptable reformatting of the answer. I just happen to favor the second one because that's something that can be done in the head. I know that the 4th root of 16 is 2. So what we really have is 2 to the 3rd. Because 2 times 2 times 2 times 2, yep, the 4th root of 16 is 2. And 2 to the 3rd I can do in my head and arrive at an answer of 8, because 2 times 2 times 2 is 8. Alright, solving or simplifying the last one, 9d, requires us to use the LCD. For those who don't remember, LCD stands for least common denominator. So we're going to use that in solving the last one. Okay, so to find our least common denominator, the factors of the denominator for the first fraction is 3. The factors for the second fraction is x, and the factors for the denominator of the third fraction is 4, and 3 times x times 4 is 12x. So that's our LCD. This is a very simple LCD, but there are other more complex ones that we'll see later in the year, and I'll tackle that bridge when we get there. So what do? Well, in our first fraction, we are missing a 4 and an x, so I'm going to multiply the first fraction by 4x over 4x. In our second fraction, we're missing a 3 and a 4, so I'm going to multiply our second fraction by 3 times 4, which is 12, but I'll just go and write it here, 3 times 4, and then that's 6 over x. And then in our final fraction, we're missing the 3 and the x, so I'll multiply the final fraction by 3x in the top and bottom. And what that does for us is it gives us 3 fractions with the same denominator. So our first fraction is 16x squared over 12x. Our second fraction is 12 times 6 is 72 over 12x. And our third fraction is 6x squared over 12x. And we can start combining that into a single fraction, where the denominator is 12x. In the numerator, we combine like terms. 16x squared plus 6x squared is 22x squared, and we're left with minus 72. And that is the simplified form. With some closer inspection, we see, and this is something that's good to do, or at least think about, all three terms in that are divisible by 2, so we can actually reduce it a little bit further by factoring a 2 out. So there's our answer, right like that. And of course there's all sorts of other manipulations. We could, if we wanted to, write this as 11x over 6 minus 36 over 6x, but then we start, slowly feeding our way back to the beginning. So I think as a single fraction, that's typically accepted as the simplified form. So I would go with this one here. All right, we're done. That's algebraic notation and rational exponents.